How are you all? It's been long that we have come up with any videos. Welcome to my channel, the channel. From now on, we will also be discussing these objective type questions along with our descriptive type and numerical type questions. And as you know, these questions will be mainly those questions that are asked in the PSUs, entrance exams, and state PSCs, assistant engineer, junior engineer. Okay, and today's topic is the casting process. We will be discussing about the casting process. 20 questions. We'll take it in the part one of the thing, and in the upcoming videos we'll be doing a lot more videos on the objective type questions that are on those questions that are being asked in state PSCs. Okay, and PSU type exams, entrance exams. Okay, let's begin. First question is, chills are used in the casting too. Chills are used mainly to provide directional solidification. As you can see, the second option, the option B, to improve directional solidification. Okay. Along with it, there is another thing called chaplets are used for the same purpose. Okay. Let's go on into our next question. The refractoriness of the moulding sand can be increased. As you can see, this is one of the characteristics of the moulding sand, and the refractoriness can be increased of that moulding sand by increasing the grain size, decreasing the grain size, increasing the water content, and increasing the clay content. The correct answer, as you can see, is the option A, that is the increasing the grain size. If you increase the grain size of the moulding sand, it will increase the refractoriness of the moulding sand. Okay, so that will result in good casting. Okay, next, this is very important one question, that is the gating ratio refers to what? Sprue ingate runner, then sprue runner ingate, then ingate runner sprue, and runner sprue ingate. As you know, it first pours into the pouring basin, then it runs through the sprue, then it runs through the runner, and it falls into the mold after passing through the ingate. So it is sprue, runner, and ingate. This is the option B, as you can see. Okay, let's go on. See, as we have discussed in the last question, that to ensure the directional solidification, chills are used in the same type. To support the core, we use the chaplets. See, the main purpose of chaplets used in foundry practice is to support the core. The option C. There are four options: to provide efficient welding, to ensure directional solidification. And the second option is about the chills. So the option C, to support the core, is the right option for chaplets. Next, what type of process is the casting process is? As you can see, welding, if you go for welding, it's what? If you go for welding, it is an addition process, positive process. But in case of your casting, it is a zero process. Nothing is added up, nothing is wasted. So it is a zero process. The correct answer will be, the option will be option B. Okay, the next question, which one of the following material will require the largest size of the riser for the same size of the casting? So yeah, it is wrongly written as option D. It should be option A. Okay, not option D, option A. Aluminium requires the largest size of the riser for the same size of the casting. Okay, so the option will be aluminium. Next, the cohesiveness of sand depends on. The cohesiveness of the sand depends on grain size and shape of the particles, bonding materials, moisture content, and all of the above. See, the cohesiveness, that is the adhesive and cohesiveness, is one of the characteristics of the moulding sand. So if you decrease the grain size, also the moisture content, and that is the addition of water, and the bonding material, that is silica, all will be going to affect the cohesiveness of the sand. So the right option for the cohesiveness is all the three, that is all the above. The correct option is option D. Then the purpose of gate is to, as you all know, the purpose of gate is to deliver the metal mold from runner into the, as it passes through the runner, as it passes through the ingate, it falls into the mold. So the right option is the option A, deliver molten metal into the mold. That is the purpose of the gate. So zinc alloy are potentially cast by die casting. The other casting cannot be used because, as you know, die casting is known for zinc alloys. Okay, the correct answer is option B. Consumable patterns are made for A, polystyrene, B, wax, C, plaster of Paris, D, none of the above. Consumable patterns are those that actually get consumed while the casting process is on. So for this, the option A, polystyrene, that is the molecular material for rubber, okay, that is used for consumable patterns, as consumable patterns. Next, question number 11. Riser is located where? Generally it is located where? It is located near the deepest section of the mold, near the parting line, on the uppermost section of the casting, and the option D, opposite to the pouring end. It is always in the upper portion so that the extra molten metal can rise up into the crust of the box. Okay, that is a cope and drag. Okay, so it is the option C, on the uppermost section of the casting. Next, cell patterns are used for option A, pipe work, option C, bends, option C, drainage, and option D, all of the above. The option is for all of the above, because as you can see, we also do this kind of shell pattern kind of things in our first year workshop labs. So as you can see, we use these shell patterns to create bands, drainage, and also for the pipe work. So the option will be, correct option will be option D, the last option. In die casting, as you can see, option A, any metal can be cast. Option B, any size of casting can be prepared. Third, the cost of dies is generally insignificant. Very high production rates. The option D will be the appropriate for die casting, because large production or high production rates are possible using die casting process. Next, about the same die casting process, what is the disadvantages? See, there are three main disadvantages. That it cannot be used for all kind of materials, okay, all kind of metals and non-metals, and the cost of equipments are also high, the second disadvantage. Third disadvantage is the heavy sections cannot be cast. So you can see, out of these three advantages, the option C has one of the disadvantages of die casting, that is the heavy section cannot be cast. Okay, yes, it is advantageous in a way. That advantage of die casting that we have discussed in the earlier question, this question number 13, that very high production rate can be possible. But in the same way, in the next question number 14, as you can see, the disadvantage is the heavy section cannot be cast. Okay, the right answer or the right option will be option C. Then the question 15. The hot tears result in castings due to, it is one of the defects in casting. So as you can see, why do the hot tears actually occur? Too much shrinkage. If your molten metal gets too much shrinkage, as you know, there is a liquid shrinkage, solidification shrinkage, and solid shrinkage. So if that kind of shrinkage is too much in the molten material, that is the liquid shrinkage I am talking about, then what happens? Your hot tears is resulting in your casting, which should not happen. So your option A is the right answer or right option, that is too much shrinkage of the molten metal. Okay, the next question is about the green sand consists of 30% sand, 70% clay, 25% sand, 75% clay, 70% sand, 30% clay. The last option, 90% sand, 10% clay. The option C is the right. As you can see, 70% sand. So 70% sand and 30% clay, and out of this 30%, around 18% or 12 to 18% is also water. And this 70% can also be around 60-65%, that is the sand. So the right option will be 70% sand, as there is no mention of water. So option C is the right answer, 70% sand and 30% clay. Okay, your next question. The molding sand should possess. As you can see, the option A, collapsibility. Next, refractoriness. The next option, cohesiveness, adhesiveness. Option C, flow ability and uh, binding properties. Okay, so these are all the good. Actually, it is not refractories, it is refractoriness. Okay, so all these are the properties that a molding sand should have: collapsibility, refractoriness, cohesiveness, adhesiveness, flowability, binding properties. So the correct option will be all of the above. Okay, your molding sand should have all these properties. Okay, the refractoriness in the molding sand is due to the presence of what? The refractoriness is whether it is for the clay, for silica, for additive and binders, and dust. So the correct option is the option B, that is silica. So refractoriness is the molding in the molding sand. Is the molding sand is not correct. Refractoriness in the molding sand is due to the presence of silica. Okay, so in this question they are asking if V is the volume, A is the surface area according to Chvorinor's equation. So your solidification time Ts is directly proportional to V by A whole square, and if you remove the proportionality sign, it will be T gamma V by A whole square, where gamma is the solidification constant. So option B is the right answer, V by A whole square. V is the volume, A is the surface area. Yeah, okay. So we have come to our last question for today, for the part 1 of casting process. So which force is acting on the core when the molten metal is poured into the mold cavity? Please do focus on the point, as the molten metal is falling into the cavity, that is the mold cavity. Which force actually does act? It is the gravity force or inertia force or drag force or the buoyancy force. It is the buoyancy force that acts on that part of the casting, during that part of the casting. Okay, so option D is the correct answer. I hope we have been able to grasp these 20 questions, and we will be coming up with, stay tuned for the part 2. We will be coming up objective for casting process and also other topics of mechanical engineering and manufacturing technology or manufacturing engineering, which will be very much helpful. Thank you, take care, see you soon.
Like a bird